MacMaths, let's do some maths today. Okay guys, I pulled it down the other way, just I wanted to mix it up, make it more interesting for you rather than just slide it across. So before you start exercise 9D, I just want you to watch this video. Although I've actually already taught you these two in the previous lesson, it's exercise 9D covers these two equations more than the other exercise where you didn't need to use them at all actually. So it's top heavy on those and it's practice with those two, but there's a concept here that I wanted to show you that you're going to come across and it's going to confuse you if I've not gone through it. And I'm going to use question 10 as an example of this, but I'm going to talk through this question with you and explain it in a lot of detail. I wish they'd decided to leave this and do these sorts of questions after the next section, which is vertical motion under gravity, because it makes more sense then. So here we go. I'm going to pose this to you. This is a particle decelerates at 2 meters per second, traveling, it's not quite worded like this, but I've just shortened the question. A particle decelerates at 2 meters per second, traveling A to B, so it's in the direction of AB, where AB is 32 meters, you know, A and B are 32 meters apart. At t equals 0, at A, it's traveling at 12 meters per second, so that's the initial velocity. So let's just have a look at this. First of all, there's A, there's B, as we always do, and some of you really annoy me because you don't draw diagrams. Okay, so make sure you do, Jack. Okay, so acceleration is 2 meters per second. Now this is really important that you start using these minuses. This is a deceleration, so the acceleration goes in at -2 in our formulas. The initial velocity is 12 meters per second to the -1, and we've got that distance in there, which is 32 meters. Okay. Right, here we go. Right, I want you to think about what is happening here now. And this is what I wanted to show you. Okay, so regardless of this now, let's just cut away from that. At time t equals 0, okay, so let's have a look at what's happening to this particle after no seconds, 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10 seconds, in 10 seconds. So we're not looking at the distance it's traveling. We could plug these numbers in and work that out. We're just looking at the speed. Well, we know it travels at this is the meters per second, okay, and this is the time. We know at time 0 it's traveling at 12 meters per second. That is its starting velocity, okay, but the acceleration is a deceleration, and -2 means it's not so much, it is slowing down, but it's not that it's slowing down, is that it's changing and it's dropping the velocity by -2 meters per second every second. So that means after 1 second its speed is 10 meters per second. After 2 it's 8, then it's 6, then it's 4. Now this is where it gets interesting, and this is what I wanted to show you. It goes 4, then it's travelling after 5 seconds at 2 meters per second. We don't know how far it's travelled yet, but we know that after 6 seconds it's travelling at 0 meters per second. In other words, as it's travelling, you know, along here, it's slowing down. At some point it stops. However, the acceleration is -2, which means it's going down by 2 meters per second every second. So if you take off another 2, after 7 seconds, the speed is still changing. The speed is changing by -2 each time. So it's now down to -2. What does -2 mean, okay, as a velocity? Well, this is, the minuses are about the direction, okay? So -2 means it's the same speed as it was at 5 seconds, but the minus means it's going in that direction. In other words, the fact that we put in 12 here is we've decided that that direction is a positive direction. Okay. So this is a positive. This is our positive direction. The minus means it's going back that way, and then at 8 seconds it's -4, -6, and -8. So it's actually speeding up again, but going in the opposite direction. So this particle is going along here, slowing down, stopping. I'll make sure that's in screen. It's started off fast, it's slowing down, it stops, and then it goes back this way. And that is why it says here in the question, find the values of t at, I'll put A there, I think it's meant to be the values of t at B, yeah, that's a B there, okay. That's why it says find the values of t at B. So if we were to use this equation, v squared equals u squared plus 2as, for instance, if we, this is interesting here, so we could use this equation to find out the value of s, how far along the line before it stops and turns round. Okay, so we know that the velocity at this point is 0. We know that u is 12, so 12 squared plus 2 times -2 is a, so if we worked out s in this equation using those numbers, okay, if s was less than 32, it's not going to reach B before it turns around and comes back. Now we know that's not the case because the question is saying what time, so we know that if we plug these in, it's going to go past, you know, it's going to reach that naught, it's going to stop and come back past the 32 meters. We know that is going to happen. And you can sort of see here -4, so you've got 4s is equal to 144, 72, 36. So it actually, s is equal to 36 meters. So it actually goes 36 meters and then sort of comes back and speeds up. Okay, so that's what's happening with this question. So I just wanted to show you that the minus, when things slow down and come out, you know, they can keep, you know, as time keeps going, the minus just means it comes back the other way. And there are several questions like that once you go past question 10. Okay. If we were to do this particular question here, the way that I would do it, the values of t at B, well, B is 32 meters away. So if I use s equals ut plus a half a t squared, s is 32, the initial velocity is 12t, plus a half a, so that is minus, let's just, plus a half times -2 times t squared. So you've got 32 is equal to 12t minus t squared. I hope you can sort of see that. If you take everything over to that side, you can see it's just a quadratic. T squared minus 12t plus 32 is equal to 0. All right, so there's your quadratic. Are the factors of 8? Yeah, there is, and you can see there that actually, it's a nice one, it factorizes, so t and t, and we've got 8 and 4 there, so -8 and -4 would be plus 32, and -8 is -12, so t is equal to 8 seconds and t is equal to 4 seconds. So after 4 seconds it's reached B, and then after 8 seconds, you know, 6 seconds it stops, and then okay, at 8 seconds it's past B again and it's on its way back this way. So those are the values of t when it passes here after 4 seconds and after 8 seconds, and it says the velocity at these times. Now can I say something about this as well, is that because the deceleration is going that way at slowing down at 2 meters per second and then speeding up, it's symmetrical, isn't it? So whatever speed it passes this point, okay, going that way, once it's stopped and coming back, okay, it's going to pass, it's going to slow down and stop and then accelerate past that at the same speed. In other words, it's going to go up here. By the time it gets back to A, it will be going at 12 meters per second again, but in that direction. So it would still have a speed of 12 meters per second, but it would be, you know, it would be classed as minus 12, because if you're thinking about the direction. Okay, so for that we can go v squared is, what are we doing actually? The velocity at these times. Okay, so, so we can go v squared is equal to u squared plus 2as. We could use that one, and we want the velocity, so we want the velocity at this particular point, okay, when it crosses here. I'll just use that one. So v squared is equal to 12 squared plus 2 times acceleration is minus 2 times the distance, which is 32. Okay, so using that formula, you've got, let's get my calculator, you've got v squared is equal to 144, 12 squared, and we've got 2 times 2 times 32, 64, times 2 is 128, so it's minus 128, all of that. And v squared is equal to 144, take away 128, that's 10, 12, 16, okay, and then if you square root v, you get square root of that is plus or minus 4 meters per second. So that means that it slows down, it's going at 4 meters per second, and then it's speeding up and it's reached 4 meters per second going in the opposite direction. Okay, so 4 meters per second that way, minus 4 is an indication of the speed it's going the other way. Okay, and that is how you know, I want you to sort of think about that if you're thinking, how is that going on? There are ones you see where it talks about, you know, a particle travelling along the x-axis and a point where x is 8, whatever, and it says what's the time when x is minus 8. Well, you just put in s, the displacement. Of course, that is a plus 32 going into our things, but you can have a minus 32 and find out how long it takes to reach sort of minus 32 here. If when you do that, you get 2 times. If we were to put in a negative displacement here, in other words, to find the time when the particle is here, you know, maybe at minus 6 meters, okay, so in other words 6 meters back in that direction. If we were to put minus 6 in here, when we do the quadratic, we would get 2 times, okay. One of the times would be the one that we want, a positive one, and that is the time from that it goes to stop, speed up, come past here, and up, you know, and then reach the minus 6. We'd also get a negative time as if it was back here, but of course a negative time doesn't exist in the real world. You know, we're from the start of our simulation, so you ignore any times that you get that are negative. You know, effectively what we're dealing with is quadratics, okay, and we're just applying a quadratic to model part of a real life situation, okay, or part of that quadratic models a real life situation. Right, I'm off to make my family paella now, okay.